Assalamu alaikum and hello everyone. My name is Rishmail Salim. I have just completed my master degree under the supervision of Dr. Muhammad Yasin Naz from Agriculture University of Islamabad, Pakistan. We presented our research work on microwave pyrolysis of pure and mixed plastic waste into liquid hydrogen and valuable carbon using sodium zeolite catalyst. Here the list of contents in which we describe our research work step by step. Our research work is related to the nanotechnology field, and nanotechnology is concerned with the design and application include the creation of innovative methods for manufacturing new products, implementing different chemicals and nanoscale materials in various fields of life. Nanotechnology's applications in agriculture, medical, animal, pharmaceutical sciences, nutrition, as well as catalysis and pollution control. Our research background is related to the plastic, impact of plastic products on human life, different types of plastic utilized in daily life, rapid increase in plastic waste due to population growth, and bad impact of plastic waste pollution on environment, plastic waste management, and suitable best recycling method for converting it into valuable products. So what are plastics? Plastics refer to a broad spectrum of polymers that obtain from highly refined crude oil. Plastics are highly molecular weight organic polymers composed of various elements such as hydrogen, carbon, oxygen, nitrogen, sulfur, and chlorine. Utilization of plastic products. As we know that plastic products play an imperative role in our lives and utilized in vast quantities due to their low cost, corrosion resistance, flexibility, durability, and lightweight. Since plastic is a crucial component in many industries such as packaging, engineering, transportation, electronics, and healthcare, its use has grown significantly over time. There are many types of plastic that we use in daily life like polypropylene, polyethylene, high density polyethylene, low density polyethylene, PAS, PVC, and PET extra. Plastic waste and environmental issue. The rapid increase in plastic production and its waste also increased rapidly, which cause environmental pollution, global warming, and health problems. There are three types of pollution that cause from plastic products like air pollution, land pollution, and water pollution. So our research motives are to overcome the concerning issues of unsustainable production of plastic waste, to recycle the waste plastic into valuable product like gas, liquid, and CNTs, to choose a less expensive and best recycling method. Recycling of plastic waste. There are many methods of recycling plastic waste, but its management and converted into valuable products such as liquid, hydrogen gas, and CNTs. Pyrolysis is the most appropriate method. So pyrolysis is defined as the chemical method that thermally degrade the long-chain hydrocarbons into smaller ones in the absence of oxygen and convert plastic waste into liquid hydrogen, fuel, and carbon in shorter time duration under the intense heat and pressure at a temperature of 300 to 900 centigrade. Types of pyrolysis process. There are main two types of pyrolysis process: conventional pyrolysis process and microwave pyrolysis process. The table and the figure show the conventional heating and microwave heating. In the case of conventional heating, conduction and convection, externally heating, it can heat externally the surface of the material, and slow heating, superficial, non-selective, and less dependent. In the case of microwave heating, energetic coupling, internally heating, rapid, volumetric, and selective, and it depends upon the dielectric properties of the material. As microwave heating is depend upon the dielectric properties of material, and unfortunately plastic have low dielectric properties. So we adopted the pyrolysis method is catalytic microwave pyrolysis process. Microwave pyrolysis process working as a principle of electromagnetic spectra in which a microwave reactor functioning at 100 centigrade with a frequency of 2450 megahertz with microwave power range from 3 to 6 kilowatt and 0.01 to 1 meter wavelength. In the absence of oxygen and in the presence of sodium zeolite catalyst, it broke the long chain hydrocarbons into shorter ones. In the rapid microwave heating process and temperature range 350 to 650 centigrade with high product selectivity. Catalytic microwave pyrolysis process is most trending to enhance polymer conversion, yielding narrower product distribution, reducing time and decreasing operating temperature. The materials and catalysts that we use in our research work is high density polyethylene, polypropylene, high density mix and polypropylene mixture, activated carbon as a microwave suspector, sodium zeolite catalyst. The properties of waste plastic that we use for high density polyethylene. High density polyethylene is strong and economical material. It has milk color appearance due to its low cost, easy of forming and break resistant. It has wide usage area. High density is widely used in production of detergent bottles, milk bottles, toys, oil containers, and more because of its high strength property. In an experiment, the liquid product is yield 80.88% at 550 centigrade. In the case of polypropylene, it is a material resistant to chemicals, heat, and extreme fatigue. It is one of the plastic with medium hardness and loss. PP has a lower density than high density polyethylene but has higher hardness and rigidity which make it preferable in the plastic industry. In some experimental studies carried out from 300 to 500 centigrade, the liquid yield increased from 69 to 82.12% respectively. Catalysts and microwave suspectors. Sodium zeolite catalyst that we use in our research work, and catalyst is required for catalytic pyrolysis to accelerate the reaction and convert plastic waste into liquid oil at relatively low temperatures. Zeolite have acidic nature and porous structure which have been shown to the most energetic catalyst. The GSM-5 catalysts were used in the in situ catalytic microwave assisted pyrolysis of feedstock to improve the properties of liquid oil and biochar. Activated carbon as used as a dielectric substance that convert microwaves into thermal energy by changing the dipole alignment of the polar molecules. Here is the microwave dielectric heating mechanism. As microwave depend upon the dielectric properties of the material, and unfortunately plastic have low dielectric properties, so we use such materials that have high dielectric properties and convert microwaves into heat energy. So the interaction of microwave and material and conversion of microwave into heat energy for decomposition of plastic waste into useful product is illustrated in this figure. We use activated carbon as a dielectric substance that absorbs the microwave radiation and convert it into heat energy. In the interaction of microwave radiation and dielectric material, the electric field directly interact with the charged particles of the material to generate heat, which cause the dislocation of charged particles from their equilibrium position. It involves two mechanisms, dipole polarization and dipole rotation. In dipole polarization, the permanent and induced dipoles of the molecule tends to align in the direction of oscillating electric field. In dipole rotation, the polar molecules rotate back and forth continuously to align the dipole in fluctuating electric field. The reorientation between rotating molecules in both mechanisms results in friction, which causes the heat generation. The generating heat is highly selective and rapidly interact with plastic waste very quickly when sodium zeolite acts as a catalyst, and then long chain hydrocarbons of plastic waste were cracked and converted into shorter range hydrocarbons of aromatic and alkenes with the evaluation of hydrogen gas as a fuel and solid char CNTs. Here is a step-by-step conversion of plastic into valuable products. It is a chemical equation in which plastic and catalysts mix together and dehydrogenation process occurred in which hydrogen is evolved, and then free radical of aromatic hydrocarbons mixed with catalyst and hydrogen to convert it into a high stable aromatic hydrocarbons with CNTs. Here is a schematic diagram of catalytic microwave pyrolysis process in which PP and high density mixed with microwave absorber and catalyst in the presence of microwaves and converted into liquid oil, wax, pyrolysis jar, and pyrolysis gases. Here is a catalytic microwave pyrolysis experiment setup that we use for our research work. It consists of many components like microwave reactor, waveguide, microwave, ceramic fiber block, pyrolysis reactor, nitrogen gas inlet, thermometer, labor condenser, oil collecting flask, gas sampling bag, cold traps, and connecting tubes. Here's the effect of plastic types on products. The table and the figure show the plastic type effect on product yield. Like for high density polyethylene, liquid oil is 56%, 24% gas yield, and solid char is 20%. For PP is 88% conversion, 48% liquid oil, 40% gas yield, and 12% solid char. For the mixture 52% liquid oil, 32% gas yield, and solid charge is 16%. Hydrogen gas yield. Hydrogen is analyzed through gas analyzer, and for high density polyethylene 81.3%, and for PP 78.4, and for mixture 80.8. The experimental result of gas composition evolved from microwave pyrolysis of waste plastic at 450 centigrade. And in millimole per gram is 126.9 for high density, 101.1 for PP, and 107 for high density and PP mixture. Here is the characterization techniques that we adopted are FTIR, gas chromatography, TGA, XRD, and STEM. There is a FTIR spectra of liquid oil. FTIR works on the vibrational energy of the molecules to find out the composition of gas, liquid, or solid material. All functional groups are made up of different bond chain and atoms. When all functional groups are combined, the FTIR analysis easily determines the specific functional group of a molecule, as each molecule has its unique vibrational energy. This property of FTIR is very important for the determination of samples, particle analysis, and characterization of multilayer films. Here is a table and figure that show the FTIR and spectra of liquid oil, which consist of functional group and compound like alkanes, alkenes, and single ring aromatic of liquid oil obtained from plastic waste. Here is a gas chromatography of liquid oil. Is a figure show that the each peak have percentage of the liquid oil, and is a GCMS profile of liquid product obtained during microwave pyrolysis of waste plastic. Chromatography is a separation technique that is utilized to change the partition characteristic between mobile and stationary phase to separate complex mixtures. Here is the chemical composition of liquid product. The graph show that hydrocarbons with their specific chemical formula and molecular weight with area concentration and retention time. Here is a thermogravimetric curves of plastic waste. Thermogravimetric analysis, also called TGA, it is an analytical technique that measures the weight change that occurs as a sample is heated at a constant rate, and is to measure a material thermal stability and percentage of volatile compounds. Is the plastic types, and initial weight loss for high density is 338 and oxidation temperature is 553. For PP is 346 initial weight loss and oxidation temperature 530. For the mixture 328 is initial loss and 580 for oxidation temperature. This is the X-ray diffraction spectra of CNTs. XRD is a material science technique for determining a material's crystallographic structure. XRD is a technique that involves the material's irradiation X-ray that calculate the scattering angle and intensity of X-ray peaks. The identification of material structure and grain size in XRD analysis depend upon their diffraction peak. XRD provides the information about the structure difference between the raw material and ideal material based on internal strains, impurities, and phase identification. In this figure, the characteristics peak shown at 002 diffraction peak illustrated the presence of CNTs, and the position, d-spacing, FWHM, and crystalline size are calculated by Schiller equation and Bragg's law. With the STEM images of CNTs, STEM show that the surface morphology of CNTs is show as tubular-like morphology of CNTs, and maximum length of CNTs is 0.8 μm and 0.9, 0.8 for mixture. Here is the conclusion. The main product are gasoline range hydrocarbons, liquid fuel, hydrogen gas, and CNTs. The high efficiency of hydrogen gas is 126.9 millimole per gram. The TGA analysis of plastic waste show the thermal degradation of plastic into solid residue at temperature range from 450 to 650 centigrade. The outer diameter of CNTs range from 30 nanometer to 93 nanometer. FTIR profile of liquid products reveals that liquid oil contain hydrocarbons with CH blending of alkanes, alkenes, and alkyl group respectively. The GC analysis of liquid fuel reveals that oil fuel contain gasoline range hydrocarbons range from C6 to C12 and heavily hydrocarbons C13 blast fraction respectively. The XRD analysis of CNT show that at 0,0 diffraction peak, the high density and less FWHM value of CNTs have more hexagonal crystalline structure. The STEM analysis of CNT illustrated the tubular-like structure morphology of carbon nanotubes. If you have any question, then you concern with us, and thank you so much for listening us.